everybody, in this video I'm going to go over Apex section 7.3.3 study, which goes over the ideal gas equation. This is the part 2 video, so if you missed the part 1 video, then I want you to pause and go back and watch that before watching this one so you can understand a little bit better. Okay, so yesterday we talked about the ideal gas equation, which if we go back was this equation right here. Pressure times volume equals number of moles times your gas constant times the temperature. Okay, so we can take that equation and sort of break it down into smaller equations. And that's what we're going to look at today. So I'm going to write the ideal gas equation up here so we remember it. So Boyles Law, this is what deals with just pressure and volume. So Boyles Law says if you hold your number of moles and your temperature constant, then your equation becomes pressure times volume equals a constant. What that means is that if you multiply your pressure times your volume, you should always get a constant number. So if you increase your pressure, in order to make that still constant when you multiply by volume, your volume has to decrease. Okay, so increasing pressure decreases volume. That's what Boyles Law says. And you can reformat this into a second equation, which is this P1 V1 equals P2 V2. So you would use this if you had a container of gas and it had a certain pressure and volume, and then you increase the pressure and you're trying to find the new volume. Okay? So this is Boyles Law. It's just talking about pressure and volume and saying that if pressure increases, volume decreases, and if you can reformat this into an equation, you can use this to predict a new pressure or volume. All right, next up is Charles' Law. Charles' Law is sort of similar to Boyles' Law, but Charles' Law is saying, let's look at just volume and temperature. So if you hold, again, the number of particles and the pressure constant, then your equation becomes volume over temperature equals a constant. Okay? And how we got that is if you have PV equals nRT and all of these are held the same, then to get this all on one side, you would divide by T. Okay? So Charles' Law is saying volume divided by temperature is always going to give you a constant number. So what that means in practice is that if you increase your volume, that means your temperature is going to have to increase as well, right? If you made this the numerator larger, if you're going to have the same number, you have to make your denominator larger as well. And again, you can reformat this into a new equation that says V1 over T1 equals V2 over T2. So this would be if you had a container of gas with a certain volume and temperature, and you increase the temperature, what would happen to the volume, right? And you can make predictions using that. So these are two laws or two equations that were made just using the ideal gas equation and just broken into a smaller part, okay? There's also something related to this called the Daltons Law of partial pressure. So I want you to think about if you had a container of gas, and let's say we have a couple different types of gas in here. We have this pink gas, we have this green one, and we have this blue one, okay? What Dalton's Law of partial pressure says is that the total pressure inside this container is going to be equal to the pressure of each part, right? So the pressure total is going to be equal to the pressure of all the pink particles plus the pressure of all the green particles plus the pressure of all the blue particles, okay? So Dalton's Law of partial pressure, it just says if you have a container with lots of different particles, it has nitrogen, it has hydrogen, it has oxygen, then the total pressure is going to be the sum of the partial pressures of the nitrogen, the hydrogen, and the oxygen, okay? So you just add up each individual pressure to get the total pressure. That's what Dalton's law of partial pressure says. Okay, and this last part, Avogadro's law, is a little bit more complicated. So to get started, first you need to understand that STP stands for standard temperature and pressure. Okay, and what this means is scientists use a specific temperature and pressure when they're looking at different types of problems. And that standard temperature is going to be 0 degrees Celsius, which we know is equal to 273 degrees Kelvin. And the pressure is 1 atmosphere. Okay? So this is called STP. Now, we can plug that STP back into our ideal gas equation. So we would get P, which is 1 atmosphere, times V, we don't know what that is. Let's say we have 1 mole of our gas. So I'm going to say N equals 1. R is always that 0.0821 times T is that 273. If you got V by itself, if you multiplied everything on the right and then you divided it by 1 to get volume by itself, you would get volume equals 22.4 liters. So this is what Avogadro's law says. So Avogadro's law, it states that at STP, at standard temperature and pressure, 1 mole of any ideal gas is 22.4 liters. Okay, so what it's saying is at STP, at this standard temperature and pressure of 0 degrees Celsius and 1 atmosphere, any ideal gas, nitrogen ideal, hydrogen ideal, oxygen ideal, any is going to be 22.4 liters volume. Okay, and another way of writing this is to say that the volume is equal to N, our number of moles, times K, where K is that 22.4. So if 1 mole of an ideal gas at STP is 22.4 liters, this says that 2 moles will be 2 times 22.4 liters, 3 moles will be 3 times 22.4 liters, and so on. Okay? So these 4 different equations and 4 new laws are just results of the ideal gas equation. So if you look at just Boyles Law, that's looking at just the pressure and the volume using the ideal gas equation. Okay? If you look at Charles' law, that is looking at just the volume and the temperature using the ideal gas equation. If you look at Dalton's law of partial pressure, this is a way of applying the ideal gas equation by saying that the total pressure in a container is the sum of the partial pressures of all of the individual types of molecules of gas in that container. Avogadro's law says if we have this standard temperature and pressure, then we can determine that all ideal gases at that standard temperature and pressure have this same volume, okay? And that depends on the number of moles. So these are 4 laws that are a result of the ideal gas equation, okay? So this is the end of part 2 for the 7.3.3 study section. So let me know if you have any questions and have a nice day.